Have you ever wondered what's behind a space mission? NASA's New Horizons scientific mission is way more than it may seem. Its main objectives are data collection of the ice dwarf planet Pluto and, later, of the 2014 AMU-69 object contained in the Kuiper Belt. The probe, launched in 2006, achieved one of the main goals 9 years later, Pluto, on July 14, 2015, and it's still on its way to the second objective. In order to accomplish it, a specific probe was built. Its triangle-shaped structure is made of aluminum and joins all the systems: power, propulsion, communication, and scientific instrumentation. In addition, New Horizons is covered in lightweight, gold-colored, multi-layer thermal insulation to retain heat and ensure the correct performance of the electronic system. The RTG (radiisotope thermoelectric generator) provides electrical power through the natural decay of plutonium dioxide fuel and turning it directly into electricity. As the other RTG-based systems, New Horizons does not have a battery for storing power. The probe was launched by the Atlas V-551 rocket, modified to suit the mission needs. It consists in a three-stage spacecraft. The first stage is an Atlas Common Core booster that works with kerosene and liquid oxygen that are consumed by the single RD-180 main engine for 253 seconds, and five solid rockets to provide extra thrust to lift the heavy launch vehicle. The next stage is composed by the center booster that works with hydrogen. The third and last stage is the main modification of the standard Atlas V-551 that allows to achieve the necessary trajectory. It works with Star 48B booster that is fed with hydroxyl-terminated polybutadiene. The New Horizons launch was originally scheduled for January 11, 2006, but was delayed to January 17 due to kerosene tank inspections. Bad weather conditions prevented launch for the two further dates. Even though there were backup opportunities in February 2006 and February 2007, only the first 23 days of the 2006 window permitted a Jupiter flyback. Any launch outside that period would have forced the spacecraft to fly a slower trajectory directly to Pluto, delaying its encounter by 2 to 4 years, because the probe will not be able to make use of the gravitational impulse of Jupiter. The probe finally lifted off from Pad 41 at Cape Canaveral Air Force Station in Florida at 19:00 UTC on January 19, 2006, and it became the first spacecraft launched directly into a solar escape trajectory. Due to the escape trajectory, the aim of the probe's propulsion is to correct the trajectory and to modify its attitude. Attitude determination is performed using star tracking cameras, inertia measurement units, and digital sound sensors. Attitude control, otherwise, is achieved using the internal propulsion system, which is redundant and consists in 16 hydrogen thrusters. The proper working of this system is essential for the scientific and communication instruments. For data handling, two 8 GB hard drives are used to retain the information that will be sent later by the communication system to the operations center. It also runs the advanced autonomy algorithms that allow the spacecraft to check the status of each system and, if necessary, correct any problems. The Horizons carries 7 scientific instruments. ALICE analyzes composition and structure of Pluto's atmosphere and looks for atmospheres around Charon and Kuiper Belt objects. ROV visible on infrared spectrometer. It proposes to study the surface geology and morphology, obtain surface composition and temperature maps. REX measures the atmospheric composition and temperature and its a passive radiometer. LORRI is a panchromatic high magnification imager. SWAP measures atmospheric escape rate and observes Pluto's interaction with solar wind. PEPSI measures the composition and density of plasma escaping from Pluto's atmosphere. PEPSI can measure energetic particles many times more energetic than what SWAP can measure. VBSDC was built and operated by students. Measures the space dust peppering New Horizons during the voyage. It is named Venetia Burney because when she was 11 offered the name Pluto for the ninth planet. The whole operation, including the launch and the proof control once in space, is managed by the Johns Hopkins University Applied Physics Laboratory, known as APL. Located in Howard County, Maryland, it is a non-profit research center that also designed and fabricated the proof. The center is also responsible for projects such as the Transit Navigation System, the Guiu and the ACE. Now that you have realized the background of a space mission, you will be able to appreciate the results obtained. We have received very high-quality pictures of Pluto. We have discovered glaciers on its surface and nitrogen under them. It is unbelievable how far technology can bring us. And this is only the beginning.